Alright, let's look at the homework 4.2, problem number 4. Alright, so we want to verify that the function satisfies the three hypotheses of Rolle's theorem. Alright, so let's look at that first. Alright, so we have to make sure that this function is continuous. If you look at this cosine function, so f is... It's actually cosine function is continuous everywhere, so this is definitely continuous on the interval from pi over 20 to 7 pi over 20, right? So it's actually continuous everywhere, so we have that. And so this is the first one. All right, second one is f has to be differentiable, right? Again, cosine function is differentiable everywhere, so there's no problem being, differentiable on an open interval. Let's see, I'm gonna have to erase this. An open interval from pi over 20 and to 7 pi over 20. Alright, and the third one is if you look at the value of f of, say, pi over 20, which is going to be cosine of, let's say, 5 times x, so it's cosine of 5 pi over 20, right? So which is what, let's see, 5 and 20 cancel out. So it's pi over 4. Right, cosine of pi over 4 is, let's see, 1 over square root of 2. Right? And how about the f of 7 pi over 20? So that's the right endpoint. And that's going to be cosine of, right, 5 times 7, so it's 35 pi over 20, right? But we can simplify it and divide by 5, so it's 7 pi over 4. Alright, 7 pi over 4, and a cosine of 7 pi over 4 is, again, I think it's pi over 1 over square root of 2, right? So this verifies that f of the left endpoint is equal to left of the right endpoint. So this is like f of a, and this is like f of b. Right? So we have all three hypotheses of Rolle's theorem are satisfied. Right? Then we just say, let's see, find all numbers c that satisfy the conclusion of Rolle's theorem. Right? So Rolle's theorem is we're looking for a number c such that f of c is actually equal to 0, right? And a c has to be between pi over 20 to 7 pi over 20, right? Let's try to find that. So f prime, so we take the derivative of this function, so we'll get, let's see, cosine derivative of cosine is sine of 5x, then multiply by derivative inside, just the chain rule, so it's 5, right? We set that equal to 0, right? Which means that we can just divide through by 5, so we want the sine of 5x to be 0, right? And so which means that, let's see, sine of 5x, so sine of what angle is equal to 0? So we know that sine of 0 is 0, sine of pi is 0, sine of 2 pi is 0, sine of negative pi is 0, sine of negative 2 pi is 0. So angle is multiple of pi, then it'll be 0. So we have 5x is equal to n pi, right? Then, so which means that the n is any integer, so which means that we can just divide through by 5 to get x equals pi over 5 times n. Alright, so we have to find the angle of this form, which is between pi over 20 to 7 pi over 20. Alright, so let's do that. Alright, so pi over 5 is, let's see, for example, say n equals 1, and pi over 5 is same thing as, so n equals 1. Then pi over 5 is the same thing as 4 pi over 20, right? So this will be actually in between pi over 20 and 7 pi over 20. So I would, so we need to include that. And how about the n equals 2, right? So that would be 2 pi over 5, which would be 10, oh, actually not 10, 8 pi over 20, right? And you can see that this is actually already too big because this exceeds 7 pi over 20. So only x value that you can have is this guy, pi over 5. That's the only one which is the multiple of pi over 5, and still between pi over 20 to 7 pi over 20. Right? So the answer is, let's see, so here, right? So let's see, Greek letter, and look for pi. So it's pi over 5 is the only one, right? So let's double check, submit for testing. Alright, I came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.